Okay, today's webinar is I would like to introduce the data science. In terms of, I would like to define, this is my key agenda for today. Okay, I would like to define, I would like to explain what is data science mean, what is a machine learning mean, and I would like to take you through kind of what is the typical life cycle of the modeling / machine learning, and I would like to show some data science applications. In every industry there are plenty of applications, but I have picked few which are a bit interesting, and where we can get a huge amount of data. What are the different data sources we have in this world altogether, and what are the key roles of the data scientist or analyst that I would like to explain. And the main focus today, I would like to give some few case studies so that you people will understand how the machine learning or what kind of algorithms are there. I mean, how the machine learning in helpful in the real time. So my focus more on the case studies. If I get a time, I would like to explain a pitfalls. That is what you should not do in the data science related things. So that I kept it as an optional topic at the end. For any questions, you can put in the chat button, and I will take up at the end. I will keep a 10 minutes window for questions related things. So when I say data science, so in a layman language, in a simple definition, I would like to say that it is getting actionable insights from the data, from the raw data. So wherever you can able to see actionable business insights or any insights from the data, which you can call it as a data science. By the way, you might be hearing the word like data analytics, data science, both are same. I think the recent 5-6 years, the data science term is got coined by Patel, who is a chief data scientist in Whitefield. It is a kind of a fancy term to the data analytics. So both are set at the ground. If you want to see that what is the technical definition or kind of a more technical definition to the data science, that's what I was saying, that data science is a blend of algorithms which includes the machine learning principles and algorithms to discover the hidden patterns from the raw data. So these, I think if you go through the Google, and you will get a number of definitions, but as I said in the starting, getting actionable insights from the data is the bottom line in any definition. So you might be hearing that what is a machine learning or those things, right? So data science includes machine learning, but not limited to. So there are any way if you are getting actionable insight, which you can call it a data science. Okay. What is a machine learning? So the machine learning is about predicting a future based on the past. So how it would predict the future? It is a simple. The machine is going to understand the past. That means you are going to train the model. There are different categories, different machine learning algorithms, which each category of data will get one algorithm will get utilized, so that the kind of black box model will get generated. That will get in the real time. If you apply the data, then you will be able to predict the future or the class where it doesn't have a target. I don't want to get into too much here. When you go to the case studies, you will get into more clear what is machine learning. Suppose if you want to ask me on a simple example where the machine learning algo can be applied, simple algorithm is fraud detection. So if you apply a credit card, he takes a lot of attributes like your gender, education, income, whether you are married or not, and everything. Those are all attributes. So finally, the target variable, what I say is that whether the person is defects or is a good guy, that is a cheater or not, right? That is the target. From the historical data, he will train the model. In a future data, if a new application comes where he don't have a whether the guy is a cheater or not, but all the attributes he collects it, if he passes that information to the existing trained model, he could able to predict that the guy is whether he's a cheater or not. That's what a simple example, but you will get to know that in the later side. So here is that the definition point of view is that predicting the future based on the past. There are a number of definitions to it, even this. So what is the typical life cycle of the machine learning model? It might be too early to say the life cycle, but what are the different stages what I would like to introduce? The first step is that you need to collect the data from different sources. I mean, there need not be a single data source like a data warehouse or a database. Sometimes you need to, for a given, before one step before, there should be some one step before, even though it is not coming to the machine learning. From a data science perspective, you need to understand what is the business problem. So for that business problem, you have identified a particular machine learning. Then you are getting into collecting the data which is corresponding, which is required to answer that business problem. So there is a zero step, what we can say, that is a business problem identification, and then for the complete life cycle is designed to answer to that business problem. Now, first step, what I am saying is that data acquisition, where you need to collect the data from different sources. It could be, but all the data is relevant to the business problem what you are trying to solve. It could be anywhere the data could be like a big data where the data is sitting in a Hadoop. Some data could be sitting in the kind of structural database. Some data could be sitting in some users' data, which is what their behaviors in the social media. Sometimes you need to collect all of them, bringing into single analytical layer. That's what all about the data acquisition. And the second step, what I would say, that data cleaning and normalization. As you know that recently we are getting a lot of data from social media where the data is not clear. I mean, they won't write the complete words and terminologies. So a lot of data, even you won't expect the proper sentences as well, right? The words also not proper, the short meaning. So there are a lot of data cleanings needs to be done. Even in the structural database also, there are a lot of missing values, there are a lot of extreme values. Those are all need to be bring into singular normalization. That's what I mean as the data cleaning and data normalization. Those are all will into second step. The third step is that where you collect the historical data, everything, train the model. Where you may need to use the existing algorithm of one of the machine learning algorithm. If it's not, you need to tailor-made the machine learning algorithm as per the data and business problem. Then once that is done, the next step is that you need to check how scalable your model altogether. So generally we'll keep the 20% of the historical data for testing purpose. And remaining 80% we use for the model training. So once we go to the model validation, once everything is done, the last step is that deploy the model for real-time usage. Sometimes we need to identify the inferences and which need to be actionable to the business. So that's what it is, the final step. So these are the typical life cycle. But when you explain the case study, you could able to correlate these steps much easier. So before getting into case studies, I would like to explain what are the typical data science applications in day and every day. You might be seeing and you might be using them. You might be not know that there are data science applications. Everyone might be using the Yahoo, Bing, and Google search engines. One of the foremost application is that internet search. So that's itself using the data scientists or machine learning algorithms to deliver the quicker and relevant answers for corresponding your query. One of the I have listed a very few examples, but there are a lot. Wherever the data is there you can anticipate that some machine learning data science work is going on. So the second application I would like to introduce, like a recommendation systems. Whenever you shop in any e-commerce like Amazon or Flipkart, if you buy one thing, they recommend something else, right? They are running affinity and market basket analysis in the backend. That's what one of the ML data science application. And the third one is that digital advertisements. You might be, whenever you watch any news channel or any Internet Explorer, if you are reading some article, something, what you click, that will be got recorded, and the advertisements are targeted to you. So there is a customer segmentation, understanding the customers. Based on that, the digital advertisements are happening. And another example which I would like to explain is the image recognition. This might be very much familiar to you all. Whenever you upload a photo in a Facebook, you start getting suggestions to tag your friends and automatic tagging. These are all image classification and recognition algorithms which are happening in the back end of inside the Facebook. So another example in recent, which is very crucial, and things are happening in faster momentum, is fraud detection and surveillances. You might be seeing that a lot of fraud cases which you notice in the NSE, BSE, and all the regulatory bodies, which are fraud detections which are happening. There are the number of fraud detection algorithms running behind. Whenever you trade or after completion of trading, will try to assess whether these transactions are real or fraudulent. Those things are your transactions are in the motive of the fraud or not natural. In another application, what I would like to say, that communications, media, entertainment. You might be hearing a lot of trending topics, social media, and which they might be using Twitter and Facebook tweets, and they analyze the sentiment analysis. Of course, this is not related to communication media. Even in politics, you might be seeing that most of the politicians or parties, the political parties, using the social media data to understand the people's concerns, sentiments, and in each of the geography, to so that they can concentrate on those issues, or they frame their presentations accordingly. So this is one of the medium for understanding the concerns. Even which you least expect might be HR space in a corporate sector. They're using employee churn analytics, whether the employee will churn or stick to the company. Those kind of analytics you can see in a HR space. One of the biggest area even recently is the healthcare. That the DNA sequencing is one of the complex algorithms. Even in the recent, we have a bigger computers, bigger infrastructure where we can able to sequence your DNA so that early detection from the cancer, and there are a number of applications even in the healthcare, which I thought of to explain you, so that in every industry there are data science applications are happening. I have mentioned a few. I would like to, in the next slide, I would like to show you where all the data sources, typical data sources, which you can see are, how can you classify them. Here you can see that previously we used to utilize, like 20-30 years back, we used to use mostly structured data and archives and those things. Nowadays, you can see that higher velocity data are social media, machine log, and sensor data, even automobiles, and even cars and everything getting equipped with the sensors, and every second to second they are passing the information. And where the machine log is some example, like a lot of apps you install in your mobiles, so your actions are got recorded, they are getting analyzed. they're in huge in volumes. So that is the reason we are getting into big data, and on top of the big data, we are trying to work on the distributed machine learning and those things, so that it can deal with the bigger volumes and in a quicker time span. So these you can, I will try to share this presentation. All these data sources, I think you can go through. You can spend more time on this. I would like to differentiate what is the role of like an analyst, what is the role of a data scientist, another role what we say that like a data engineer. What is the differentiation? Is that data engineer is the, if I have not mentioned in my presentation, but that is the one which typically starts with. So data engineer is the one who can collate the data and provide the true picture of the data and summarize the data. He should be able to play with the data. The typical skill set might be he should be able to parse and query it. If it is unstructured data, it is mostly from the SQL databases. If it is unstructured data, you need to play with Python and Java, Hadoop related distributed languages, where you can play with the gigabytes of the data in a distributed manner. So data engineer, if it is a structured data, he is supposed to be equipped with the SQL related languages, whereas in social media data, then he should pick up something scripting language like a Python. That's what the data engineer, what I would say. We have a low intensity role called data analyst. So what he will responsible is that he takes the data from the data engineer, or he himself prepares the data engineering role, and he explores the data analysis. I mean, he should be able to correlate the data. He would be able to. There are a number of applications where you doesn't need hardcore machine learning to solve those problems. So data analyst is the one. He should be able to exploit, provide the trends and those things. He should be able to do it. Whereas a data scientist, in my terminology, data scientist is a kind of all-rounder. He should be able to play with the data. He should be able to explore it. He should be able to utilize the machine learning algorithm. If he won't find a proper machine learning, he should be able to implement it. If it is a higher-end data scientist, or sometimes you need to tailor-make those solution algorithms as well. At the end, you should be able to deploy it in the proper way, and that need to be even relearning and those things he should be able to take care of. That is what I mean data scientist. I hope most of them are might be passionate role is a data scientist role. I would like to explain what I mentioned is that I would like to spend more time on the case study, so that you will, you will feel of what the data science mean or how it is getting utilized. First example, I would like to say that connected cows. If you want to have a video, this video is is there in YouTube. You need to search with the connected cows term. You will have very good videos as well. What the problem is that the connected cow is that the objective is to increase the pregnancy rate of cattle, but how? You know that there is a period called in cows estrus, which is able to detect whether it is a cow is able to become pregnant or not. But the detection itself is very low probability as of now. In the current normal way, it is a 55% of detection rate. Once you detect it, the pregnancy rate is 39%. So, which is very low rates, which you can say. But why it is a low rate is, we'll explain what is the research background. This is the current scenario, the top one. What it is the current problem is that detection time, I mean is that at what time and when the cow is ready to get pregnant. That's what we call estrus. And once it is pregnant, that is pregnancy rate is 39. If you multiply these two, it would come around 28% success rate. So if you can detect well, here is that very low, which the second you can't have any control, but you have a little bit control, but if you can detect well, that will help you to improve the 70% higher. So there are some researches what is say that stress lasts for only 12 to 18 hours. That will happen every 21 days and occurs mostly in the night time. That's sad part of it. So the farmers won't able to identify it. That is a bigger problem. So how to solve this problem, or is there any scope to solve this problem? What we learned from the research is that cows become more active during the stress. When it is active, it is tend to make more steps or more. It tend to walk more. So what the solution is that this is one of the solution which Microsoft only provided. So the cows are equipped with outfitted with the pedometers, which is you can see in the you can tie it with the leg. It is simple. It detects the number of steps in an hour or in a time, in a minute time, so that in a stress period, the cow will make more steps, whereas in other normal nights it make lesser number of steps. Here you can see. Okay, we have two lines. You can say one is a yellow line, another one is a green line. In a yellow line, the green line is a cow which makes the number of steps on a normal period, whereas when the stress happens, the number of steps are peak. I mean, you can see the sudden jump. Even that jump you can see around 16 hours, right? So it is very easily, so that it is all together. There should be some counting machine which we have put it, and that is very strong, and it is okay, scalable, and it can work on any place and rough farm places. The second is that once it is higher, it altogether it required to drop a message to that farmer, corresponding farmer, so that he do the consequent tasks what are required. Another one, what the results are analytics are telling that even within that, once you identify that first half of the period, if you do injection whatever it is, insemination, it is most probably a female, whereas in second half is that most probably it is a male. So even that also the data scientists could able to identify that. So this is one of the example I would like to explain. But altogether, you know that this doesn't require any proper algorithm. This is simple exploration, what I can say here, but it is useful. That's what it is getting insight, and it is getting the improvement of the business of around 75%. So I would like to give another example where we have done kind of used machine learning algo. So this is a early warning for a part failures in an automobile. You might be knowing that in a very high, the background of this problem is that there are a number of costlier cars are there where they have equipped with a lot of sensors. Sensor is the one provide a symptom or a diagnostic code if something is failed. So, but in our roads and in a current outdoor real market, what it happens is that, but those even those sensors supposed to provide some symptom of the failure of the particular part. That is the real objective of the uses of the sensor. But some of the times, the sensors multiple sensors may work for a particular problem. The reason is that assume that some in a car, if the engine got failed, so it forced to fail other items also. Then the analyzer could not able to solve the problem. There are a number of you make some the driver made some mistake or not forgot to lock it. Then it will throw some sensor. So some what we call it is a DTC, diagnostic trouble code. So in general, the users or the analyzer could not able to take any actionable on just watching the sensor, because in every day he could able to see some hundreds of the diagnostic codes, and also he doesn't know that the real problem when it comes is he has to be fix the problem immediately, or he has to solve the problem like within a 1 week time. How much he has, he doesn't know. So what we thought of is that, do you have any patterns within the trouble codes? I mean, sensor driven trouble codes before any real problem happens. That's what we call it as a pattern identification. That is the algo which we have used. Here is the what I would like to show, the how the information flow happens when a real problem happens. You know, right? If some problem before comes, the users use it to type something or message something in the social media, but it is very rare to utilize it. I mean, he gets something uncomfortable with some particular thing. He may put something in the message in the social media, but that is not 100% sure. But sometimes he can call. He may call to call center something. There are here in the third step, we are getting some sensors which we could not able to utilize in the current situation. After that, real problem will happen. So before that, there are a lot of things are there. It has a scope to identify the problem before the actual problems happens. So after the problem, as you everybody knows that he has to take the appointment and the delivery, dealer visit, and the dealer has to diagnose it, and after that part arrival and repair, and after at the end of the last is that he has to submit the warranty submission. So is there any in the current system we are not able to utilize the sensor information or call center information, anything. We are acting once it is getting failed. So that is where the problem or the scope for problem solution. Can you identify the problem in advance so that you can minimize the warranty cost at the and also you can improve the customer confidence, and there are a number of applications utilities if you can know that in advance. So I think this is a little bit not required. I mean, the same thing I have mentioned in another graph. You can skip this side. But what is the typical? I will come back to this. Before that, I would like to show the output. Then I can come back to that. What is the flow of the modeling which we have? You can anticipate to utilize it. See here, what I was saying that if you know that there is this is the output what we have delivered. There is I have masked the actual sensor variables. I typed dummy numbers. So there is a sensor trigger which came BXX1. Once it got, then you got the 25% or 26% of the confidence that the electrical and battery failure symptom it is. That's what it says. But it has a very low confidence to call the car or something, or give a message or something. But if you wait some more time, or after 83 or 84 kilometers running the car, you would anticipate some other sensor which is BXX2. Once this is received, you will get a 60% of the confidence that condition probability that the electrical and battery failure will happen. For how many kilometers the actual problem is there? That's what the solution we have developed. And after that, you will find another sensor where it 100%, 85% confidence that the failure will happen. And after that, 290 kilometers actual failure is happening. So this is the what pattern what we want. So that's what we have delivered in that project. So because identifying the crucial ones which are having the among all other cars and across the cars, which is the novelty in this. Whereas if you identify a single sensors which are, as I mentioned, thousands of the sensor symptoms will come in every day, which you can't identify the case by case. So if the analyzer, even the service guy, if he know those patterns related things, he can keep the top 5, 10 or 10, 15 patterns. Whenever the particular symptom comes, then he can watch those things, and he can give an intimation, he can call that customer for service, those things. Now I would like to explain what is the pipeline or a solution pipeline which we have, which we can design. Here I have mentioned two kind of pipelines. If the data is in big data, then where you are, the data can be stored in the database. So both the scenarios I have provided. If the big data, then the data you can say that sensor and warranty information, actual failures, which we have used historical actual failures as to identify the patterns. This is the data warehouse where either of the places which you can store. And if the data is the next step, as I mentioned on the data machine learning, we need to pre-processing and data cleaning and kind of normalization which we need to do to form the sequences. So I mean of sequence is that whenever the actual failure happen, what are the typical sensor trouble codes which are came before 4 months, which are completely like sensor 1, sensor 2, something. That is a sequence which you have given as an input. So that can be done either with using Hive, or if it is a traditional database, you can use the SQL to get it out. The third is that which we have applied proper modeling, which we call it, this is a affinity or a FP growth, where we call it Mahout, which is in a distributed environment, which is a layer in the Hadoop layer, big data Hadoop layer. If it is in a traditional databases, we can use R or Python or SAS or SPSS. There are a number of tools are there which you can utilize the machine learning algorithms. So one of the decent and open source is R, which we recommend for at least for the earlier even professionals also. So that is the one which you can utilize in this step. Once it is done, there are a number of post-processings are there. Once the pattern is identified, as you see the results, you can see that number of kilometers are there before sensor to sensor. That's we need to do the post-processing. That's like we generally recommend Python kind of thing to identify the remaining the delta information from the patterns. So don't expect machine learning or any algorithm will provide you 100% actionable insight. We need to do some post-processing. That's what we lined up in the next item. And I think this is here is not a deployment. It depends on the service center how they want to deploy. That is a complete pipeline. This is another case study which I would like to use. This is the output. I have a few more minutes, around 7-8 minutes. I would like to take this chance to explain the few pitfalls. I think that as an early thing, which you might be not required too much, but you should know that what you should not do. Which you very few places will be mentioned these things, because every time you get to know that what need to do, but you would not mention, you won't get into what not to do. I mean, what the things you need to take a caution about it. So there are I would like to call out some examples, because that's the way I would like to explain. Generally what we do is that whatever the data we have, we'll come to conclusions with that data. That's the human tendency. So we never question ourselves that our data, is it a complete population or representation of the population? We rarely question ourselves, because we don't have an option. We end up using whatever the data we have in our, I mean is that in the current company or in our database or whatever it is, then we come to conclusions. So we need to know that whether these conclusions represents the total population or the particular segment of the population. Example, current in recent marketing things, using Twitter data and identifying the trends and everything, and that Twitter data, you know, they are representing the Indian population, that speeches and topics and everything. That is not the real, because the Twitter users are mostly IT people or young population or entertainment related people. So that really does not represent, at least for Indian population opinion, you can say that. So if you know that this is representing only you, if you put a caution, then it's well and good. But you should not make the conclusions on behalf of the Indian population or a complete more population, which only one segment of the people are using the providing the sentiments or any tweet information. Second, what I would like to say caution about that correlation dilution. Whenever we get a data, very easy thing is that everybody want to find a correlations between anything, any two things. Whether they, our psychology is that hunt for correlation, which lead to bad conclusions most of the times. If I want to give some examples, the Facebook growth while it is growing, Greece was descending into debt crisis. Is there any correlation between them? Nothing, right? So they are just coincidental. Just some time at the same time, both things are happening. So there are number of scenarios where you find a correlation technically, literally, if you put a correlation formula, but they are nothing to do, not related to anything. That's what I want to show. The third thing is that implication of the causality. Whenever we find a correlation, assume that there is a real correlation, but we come to some judgmental mode like a cause and effect relationship. What from me is that establishing a cause and relationship is a cause and effect kind of relationship, much stronger and complex thing compared to the correlation identification. 1 out of 10 may have a cause and effect, remaining are just correlated. If I want to give few examples, in US at least, in ice cream sales and drownings, the deaths in the sea are correlated, but there is no cause and effect relation. The ice cream sales are not causing any deaths. That's we know it. That is the data with what we want to show. But literally, if you put a correlation, it will a strong correlation. And there are some studies in educational academics are saying, in IITs at least, the number of hours the student sleeping and is highly correlated with the GPA, what is the grade point, what he is getting. Might be correlated, but it is not the cause and effect. If you sleep more time, you will get more grade. That is not the case. These are the things. I'm done with my session. I hope I'm in time. If you have any questions, I will take up. If you people doesn't have any questions, I would like to add one more topic, because the time is there. I would like to explain what are the typical career opportunities in the data science domain. In a current scenario, which like 20-30 years back, very few companies which are very specific to data analytics, like Narasimha, Fractal, and very few companies which use to deal data scientists and machine learning things. But in a recent times, at least from last 5-6 years, I didn't see any company which doesn't have any machine learning work or any data scientist work. And the paradigm, that is what I have identified. Every company needs a data scientist, and it is a huge demand in the current times. And when you say, but there are some companies which needs more data scientists, where there are some companies which have lesser data scientists, like Google, Microsoft, and these kind of things. Like there are very focused mission data scientist questions. There are a number of companies which only focus data scientists companies, like Narasimha, and there are a Fractal. Those companies are there. Even Facebook has having a lot of data scientists. There are a number of more opportunities there, but in the recent times, almost all companies required data scientists because they need to utilize the data. and get the insights, the data. The shift, what we can see that all the business decisions are taken based on the data proofs or data actions. So the business running on the data outcomes. That's the shift what we have seen. The second thing is that when we are IT or engineering so-called people, so in the current, there are a number of products which we are developing apps, or let it be app or any product. It is a pure engineering product, but now we are trying to add the machine learning components or layers on top of it. So that's what we have seen. You won't find a project or any complete work which is 100% machine learning work, but there are plenty of the projects which are happening in the recent companies where there are engineering products, but they are incorporating 30-40% machine learning components and functionality inside that. So they are optimizing the machine learning functionality in the typical apps. What are the apps you would see? Even Google Maps and any app which you have in your mobile or Android, all of them having machine learning components, whether it comes, let it be shortcut paths or recommendations, or there are a number of things which are happening. So that's what the skill set you might be required here is that I don't see background much correlated to the data science thing. I mean is that like a computer science guy is more suitable, or electrical. That's I don't say, but the person who has a more mathematical appetite with logical sense is more suitable, and irrespective of the background. What I mean to say, that's what I believe. But whoever has a passion in logical understanding and correlating and playing with the data, all can get excelled in this domain. Little bit maths is there, but that is over time get digested. Can get digested. So if you are looking at a data scientist role, I don't see any boundaries. Like this is the role or typical work from the business objective. Once the business objective you found it, if you identify a business problem, until you get the solution to the business problem, what are all you require to do? Those are all you have to do. That's what the data scientist role I would define. But some companies, they put like a data engineer, data like a machine learner. The later section is analyst or somebody who explains the outputs to management. But in a future, that won't be the case. The person should be able to take care about the complete life cycle. What I mean is that. If you have any question, I would like to take up. I hope I have answered. I explained whatever I planned. If you want have any suggestions, if you are coming from so-called engineering profile, better to understand some statistical mathematical terminologies at least. Don't get into too much deeper, but there are so many terminologies which getting utilized in the machine learning algorithms, like a p-value. What is a t-test? So there are very few. Get the understanding, and at the end of the day, once you do the machine learning algo, you should be able to explain the outcome more. I mean, you need to consume it. You need to digest the parameters what are outputs in the machine learning algo. So for that, getting a few definitions or a way to use how to use those values. If something say p-value is a 0.05, what it means, you need to understand. For that, I think there are very when you are understanding any algo, you get into what are the terminologies which are present in that algo, or in like if you identify a clustering algorithm, there are some error related terms are there. and those you need to get the understanding of that. So whenever you're getting a particular ML algo or any machine learning algorithm, you just don't ignore the statistical terms or which tells the significance of the outputs. You get the understanding of those terminals in full. You can utilize. There are a lot of short videos are there in YouTube. You leverage them. So understand that. That's my suggestion for those guys who come from the engineering background. And as I already mentioned, I think the tools and so-called any packages or the hands-on, which might be for a data scientist related, as if you are in a college or something or education thing, better to get into like a mathematical tools like R for data cleaning and something. Python is very suitable. So those are very mathematical in a way that you can get into those platforms in a couple of days. That's what I mean. So those two are recommended for the guys who are planning to move or take the passion and who have our passion in the data science. If any of the person has any question, I would request the person on the chat board. You can drop a question so that I will take up those things. Okay. Sorry, students, I am not able to see your questions in the chat button. I think couple of people might have raised the questions. But I hardly see the questions in the chat button. Just I'm trying to find out a way how to see that questions. Okay, if you can able to send the questions to the organizer, I will respond it in offline. I say I don't understand some way, I do not able to see your questions. Thank you for the day.